Let's find antiderivative of the inverse tan of x. Now some books use notation arctan of x. So these are the same thing. However, inverse tangent of x is not the same as 1 over tangent, which is equal to the cotangent of x. Those are totally different things. We'll be finding antiderivative of inverse tangent. The integral of cotangent is done earlier in the Calculus 1 section, so you may refer to that. These are totally different things. We'll be using integration by parts to solve it. Remember, integration by parts formula is the integral of u dv equals u times v minus the integral of v du. The idea is to let the unknown integral be the integral of u dv. Identify one part of it as u, the other as dv. Find du, find v. Express the integral in terms of the right hand side of this formula, and then hopefully the integral on the right will be easier. That's exactly what will happen here. Let's proceed then. Our integral of inverse tangent can be written as follows: inverse tan of x times 1 dx. So we want to, part of it will be u, part of it will be dv. Notice that it's impossible. If we let dv equal to inverse tangent of x, then to go from dv to v would be exactly to find an antiderivative of inverse tangent, which is what we're trying to do. Therefore, the only possible choice is to let u be the inverse tan of x. That leaves dv to be 1. Differentiating, remember the derivative of inverse tangent is 1 divided by 1 plus x squared dx, and v could be any antiderivative of 1. It could be x plus 5, x minus 10. 99.9% of the time we'll let the constant of integration be 0, so we're going to do that in this case, and v is going to be x. So the integral we have, which is inverse tan of x, we're calling this the integral of u dv. It is equal to u times v, therefore it's x times inverse tan of x. So that's just plain u times v minus the integral of v du. The integral of v du is x divided by 1 plus x squared. So this part is our integral of v du. The idea of integration by parts is to hope that the integral on the right is easier than the integral on the left, and of course it is. This integral can be done by substitution. So let's go ahead and do that. X divided by 1 plus x squared. We're going to make use substitution. Since we already use u, we'll use w. Let w be the denominator. 1 plus x squared dw dx equals to 2x. And so solving for dx, we're going to have 1/2 dw equals x dx. So you can see in the integral we have x dx right over here. We'll replace that x dx with 1/2 dw. So the integral becomes very trivial. X dx is 1/2 dw. The denominator is w, so this is our integral. We know that that's 1/2 natural log of absolute value of w, and then replacing w with 1 plus x squared. Notice 1 plus x squared can never be negative. We don't need absolute values. You can have them there, it's fine, but it will be redundant. So it's 1/2 natural log of 1 plus x squared. So let's return to the problem that we were trying to solve. We wanted to find antiderivative inverse tangent of x. We found that that was equal to x times inverse tangent of x minus the integral of x divided by 1 plus x squared. We just evaluated that integral, so we end up with x times inverse tangent of x minus 1/2 natural log 1 plus x squared. We can now add the constant of integration at the end, and that's the antiderivative of the inverse tangent function. For more